kind of see it looking like a function or looking like a linear equation. So the value of the copy machine is equal to a $900 loss per year combined with the original cost. So this is a beautiful linear equation. Sorry, I didn't write f of x, f of x. The output, the adjusted value, the result is equivalent to losing $900 per year added to the $4,500 that you paid for the thing. Question A says, what will the value be after 8 months? How can I use 18 months here in order to find a new value after 18 months? Notice the word problem has it losing $900 per year. So what can I convert this to? Because this is months.
3 halves.
3 halves or 1.5, you bet. That means the new value is negative 900, and I am going to use 3 halves because that'll reduce our 900 quite nicely, added to 4,500. Why? Because that is equivalent to 18 months, 1.5 years. Cutting it in half gives me 450. What's 450 times 3? Anybody get that far yet? 1350, I think. So the result is going to be that, 4,500 minus 1350. Jazz, what do you think of that? Not too bad, right? This one is not too bad. So to answer the question, we took the number of years, which was 1.5 based on the 18 months that they gave us, and inputted it for the X value. B is different. When will the book value be 1,200? Or when will the machine value be 1,200? Book value, that's like, they call it, for cars they call it a Kelley Blue Book, but when will the thing be 1,200? So again, look at the equation. The new value is equivalent to the loss per year, which we already know is 900 per year, combined with the original cost of the thing. We know we're losing 900 per year, and we know the original cost of the thing was 4,500. Question B asks, when will the book value be 1,200? How can I use that piece of information? And what do you think the 1,200 actually is? Is it a X value or a Y value? Is it an input or an output? It's a Y value. You're right. So you're going to plug that in right there. So here's a really quick table for you up top. In 1.5 years, our thing will be 3,150. They want to know in how many years will it be 1,200, whereas the previous problem gave us this and had us solve for value. Are we able to figure this out, you think? Subtract 4,500 and solve for X. So negative 3,300 is equivalent to negative 900 multiplied by the number of years it takes to get there. I came up with 11/3, which is, what, 3 2/3? How would you equate that to years? 3 years, how many months? Yep. There's your answer. 3 2/3 years, otherwise known as 3 years, 8 months. All right. I'm just trying to decide which one I want to do next. We're gonna do number 3 next. Okay. And this is a totally different problem. A plumber charged $110 to be there 3 hours and $160 to be there 5 hours. At this rate, how much would he charge for an 8-hour job? Okay, here's where it's tricky. This one is tricky if you don't know anything about this, which most of us wouldn't. If you call a plumber or an electrician, they charge you just to walk in the door, okay? That's, they call it like a, I just call it a fee for showing up. I can't remember what they say. We have a house call fee or something, okay? So this isn't just a flat hourly rate. And they do that because what if they get to your house and the job takes 5 minutes? It's a waste of his time to drive to your house, fix the thing in 5 minutes and leave and only charge you an hourly fee. That's why if you notice, $110 for 3 hours, let's just take that as a flat rate per hour. 110 divided by 3 is $37. Okay, I'm gonna round it. Actually, I will leave it like this just to show it. Per hour. The other one was $160 for a 5-hour job. $160 for a 5-hour job. And look at that, $32. So clearly, there's not a clean rate per hour here. Okay, it's not like when you work at wherever you work, where you go to work, you clock in, you clock out, you get $8 an hour. When you're dealing with somebody coming as, for like a house call, there's a flat fee associated with him just showing up. Okay, and that's what they don't make very clear in this question. So I'm going to show it as the cost of a visit for this guy, for a plumber, electrician, is equivalent to his cost multiplied by the number of hours he's there, added to a flat walking in the door and showing up kind of a fee. Yeah. Okay? Fun, right? Okay. Now that I've translated into something that makes a little more sense to you, you're probably able to figure out some of this information here. Or are you? Let's see what we know. Do we know some stuff? Well, we know that for 110, or for 3 hours it's 110, for 5 hours it's 160. Well, how can I use that? Well, I can figure out that the change in the cost over the change in the hours gives me actually a slope. Cost M. Change in cost. I figured out that the change in the cost and the change in the hours resulted in this. So now I have The result, or the cost for the visit, is 25x plus a flat fee. Still don't know what that flat fee is, do I? But I was able to at least figure out an M value by finding these changes. Can I solve for B somehow? By using maybe one of these costs? I'm going to use 110. That's the easier of the two. 110. And I already have it worked. 25 times 3. Where am I getting those numbers? Because for 110 bucks, you got 3 hours worth of plumbing done. After I subtract my 75, I think I get 35, right? Looks to me like his fee for showing up is 35 bucks. So I had to go through and extrapolate an awful lot of data in order to get from here to there, didn't I? Okay. So if that's the case, then the function is f of x is 25x plus 35. This is per hour. This is total cost. Nobody's brain's bleeding yet, right? The question is, how much would he charge for an 8-hour job? Well, now it's easy. Plug in my 8 hours, 200 added to 35, and I get my amount. But it's getting there that makes it difficult. It's just the getting there that makes it difficult. Let's look at number 5. I know it's hard. Let's look at number 5. So Allied Airlines charged $90 to fly 260 miles and lost my place. $150 for a 500-mile trip. This is going to be real similar to the plumber scenario in that you're not going to find it's obviously $1 a mile or something simple like that. You're not going to find that. You are going to find, though, that it's total cost is equivalent to cost per mile, probably, added to, I would say, a flat fee as well. I'm sure it's more complex than that, but we are able to find our distances. We know that our distances are these. So these are going to be what you're going to use for your x values. And we do have costs for trips, which are these. So this is what you would use for your y values. Do I have a cost, though, an m value? No, but I believe I can get one. I can use change in y over change in x. And I'm going to do 150 minus 90 on the top. And I'm going to do 500 minus 260 on the bottom. And that should get me what? 60, 240s. What is that, 1/4? Which now I have a cost. An m value. So as you input mileage, and if we had a b value, a flat fee, we would be able to find total cost based on the trip information that they give us. So I'm going to jump to the top of the next page here. So right now I have y is equal to 1/4 x added to b. I don't know b values, but I do know some x and y values. I do know a 260-mile trip cost me $90, and I do know a 500-mile trip cost lost my place, $150. Remember, I used this information to obtain that. Can I solve for B by plugging in one of these? Definitely. Which one do we want to use? Doesn't really matter, does it? 260 and 90? 1/4 of 260 added to whatever that flat fee is will give me $90. So you should have 65. I'll give you that. Looks like B is $25. So you know what? To fly the plane, that's pretty old numbers, I'm sure. You're automatically going to pay at least $25. So my now completed word problem is the cost to fly my trip, whatever it is equal to 1/4 x added to 25. I had to do all that work before I could even address the problem, which is, what if they were 1,000 miles apart? And this is miles, right? And this is cost. So where does 1,000 go? As an x or as a y? X, because it's miles. 1/4 of 1,000 added to 25. What's 1/4 of 1,000? 250. You end up with 275 for the cost of this particular trip. That's correct. Holy cow. That would be absurd if you could actually get that. Well, maybe you can. That's number 5. Do you notice that these last two problems are kind of talking about B values as like a starting point, or a, no matter what, you've got this. For the plumber to show up, it's $35. And then some things add to the cost. In order to fly the plane, it costs $25. And then mileage rate affects the cost. Now, this next problem looks a little bit different. It's the last one I want to do with you guys. This is number 7. And I know these take a long time, but I think you guys need it. 15 days after Alan began his diet, he weighed 176 pounds. So, sounds to me like we're dealing with diet time and weight, doesn't it? So the first statement they gave us is 15 days after beginning his diet, he weighed 176 pounds. Okay, so time on the diet, weight. After 45 days, he weighed 170 pounds. Lost 6 more pounds. Okay, question A says, how much did he weigh at the beginning of the diet? Okay, so it sounds to me like this is very similar to question 1, and I'm going to show you why. Question 1 was,
But in 30 days, he lost 6 pounds.
Yes, that's good.
Yeah, so in 30 days, he lost 6 pounds.
Yes. But we don't know what he started at.
Okay.
We do know that his new weight is based on whatever he loses, I'm gonna try and write it in a way that kind of looks okay. Whatever he loses in a certain amount of time, and notice I'm using a negative number there, I'm doing that on purpose, added to what he started at, right? So like we could say, well, if we knew he was gonna lose a pound a day, that's easy, but we can't really say that for sure. We can't say anything like that for sure, but based on these numbers, we know that his weight that he currently has is based on his losses, Lord willing he's losing weight, over time, or with relationship to time, added to what he started at. And we want to know, this is exactly what we want to know, which happens to be the B value in this, the way I'm writing it anyway. So if this is X and this is Y, can we use this information to find change? To find M? We're going to do 176 over or minus 170 over 15 minus 45. You're going to notice that's going to give you a negative result. So you're going to end up with a negative 6 over 30. Is that right? Which is a negative 1/5. But the key there is to keep it negative because we are losing weight over time. If you were to graph this, it would be a downhill thing until he stabilized where he was. So now I have my new weight is equivalent to negative 1/5, whatever time frame we're talking, plus whatever his weight was when he started this whole puzzle. We can use either set of coordinates to solve for B and then extrapolate our answer. You guys want to do 15 and 176 or?
Yeah.
All right. We'll do negative 1/5, 15 added to B. That should be added to B is equal to 176. So is that negative 3? Am I right so far?
Yeah.
Sorry, thank you, Percy. Add 3, and you should have a B value of 179, which means he started out at 179 pounds.
I have a question.
Go,
I don't know if this is accurate, but I figured that out.
go.
Because I did, in 30 pounds, he lost 6, and 15 is half of 30, so I just added 3 to 176.
Yeah, you
But I
found
don't know-
slope. You found slope. It sounds to me, it sounds
But
to
I
me,
did it on my head, and I got the same answer.
yeah.
I just didn't know if that, like, would work. I didn't know if that would work every time, though, is what
Well,
I'm saying.
I'd have to see what you wrote down.
Okay.
And it sounds to me like, though, what you told me is the change. You told me what happened. All right, so f of x, let's finish this up really quick. Negative 1/5 x added to what he started at. Shh. They want to know, how much did he weigh at the beginning of the diet? That's this. And when will he get down to 165? So the new weight is what we want. 165 is equal to how much time will it take him to lose it? Subtract 179 from 165. Negative 14 is equivalent to negative 1/5 x. 70 days. So that's a pretty fair thing. You don't want to lose weight too fast. I know we all really would rather lose weight fast, but